The Cycle of Krebs by Audra Noel. Let's start with a circle. Now, circles are not that good for memory, so we transform our circle into a square. And now we have 4 corners and 4 middles. And those are the 8 positions where we are going to put the 8 classical compounds of the cycle of Krebs. We start with the first one. Citric acid was discovered as in lemons and is the citrate. And it goes into the first corner. The second one is a very similar compound. It's called isocitrate. It's only different by the position in one OH group who has moved. And we put it here in a slightly different angle. The third one is alpha ketyl glutarate. Alpha ketoglutarate in the third corner. The next one is succinyl coenzyme A. The succinyl is represented by an octopus full of suckers. Succinyl. And the coenzyme A is a very large molecule, which here works almost as a handle. It's large and stable, and it has one important point here, where the action takes place. Here we will have an S, a sulfur atom that hooks the coenzyme A to our octopus. Succinyl coenzyme A takes the bottom middle position. Then we're going to have more suckers, another octopus. This one is on its own. Is succinate. Succinate takes the other lower corner. Now we arrive to fumarate. Fumes, smokes, smoking, fumarate. The last corner is for malate. Malate. Everybody will tell you that eating apples is good. So we have put a malate on top of the apple. Malate, also Latin for apple, where it was discovered. And our final position is oxaloacetate. We start with an ox, which is a bull with no balls, like this one, and acetate, the material most commonly used for glasses and spectacles. Oxaloacetate. Those are our 8 compounds, and now we are going to see what else happens here, what is coming in and out of this cycle. Okay, now we are back to the same cycle, but we have the elements represented here. So let's have a look at the number of carbons that each compound has. So we start from the vertical line here. The 2 lemons will have 6 carbons each. The alpha ketoglutarate will have 5. The succinyl coenzyme A 4. And from them, they will all have 4 carbons. So everyone here has 4 except the vertical line that they start with 6, 6, 5, and then move into 4. So knowing that there are 2 molecules of CO2 that leave the cycle, it's quite easy to see with that there should be one between the isocitrate and the alpha ketoglutarate, and another one between the alpha ketoglutarate and the succinyl coenzyme A, because we are going from 6 to 5 and from 5 to 4. But how to remember that? So let's boil the kettle. We put a fire, whatever is in the kettle gets boiling, and what comes out of here? Well, no water vapor, but two molecules of CO2 that land one on each side. The next thing that leaves and enters the cycle is water. One molecule enters between the citrate and also leaves again before the isocitrate. This is because there is an extra compound that we haven't represented here, which is part of the cycle sometimes, but it's so fast. Basically, there is some water exchange there, but it comes in and it comes out. There is another molecule of water what enter here. Obviously, between 4 and 6, something else have to enter the cycle. And the answer is acetyl coenzyme A. Is not represented here, but also we need to know there is a molecule of water coming here. And what we can do is to have this ox actually spitting in the lemon. The next one comes in here between the fumarate and the malate. And perhaps we can remember that by having a little bit of a fountain coming out of our pipe to represent the molecule of water that goes there. And the next important thing that happened in this cycle of Krebs, going in the direction of the needles of the clock, which is the traditional cycle of Krebs. There is a reverse cycle, but this is another story, is the production of energy. And here we have all the energy that this cycle will produce. 3 NADH, 1 FDH, and 1 GTP. This is the easier one to remember. It is given from one octopus to the other octopus. They just pass it over between themselves. Is the smaller energy formation in this cycle is more or less equivalent to an ATP. Then is this one, which is slightly larger, is equivalent to 2 ATPs. And this one is going to be here. Basically, the succinate is going to give it to the fumarate. But let's put it in here at the bottom, between those two. And then you have 3 more. Those are roughly equivalent to 3 ATPH. And we can just put them anywhere else where there is not another battery and there is no water. Water and batteries don't go well together. So we have one space here between the malate and the oxaloacetate. And the other two, the only space are between the two, where the two CO2 are. And there we have here all the energy production in place. So one turn of this cycle will do 3 and 3, 6, 1, 7, 8, 9, 10, 11, and 12. Roughly 2 molecules of ATP are produced each one turn of this cycle. Let's have a look at this in a different way. And here we have the same elements represented in an art form. You can have a look at the piece of art at the beginning of this video. There are several others in my website. But let's go through this one. We have the same elements starting with the citrate with 6 carbons. Water comes in and out, and we arrive to the isocitrate, 6 carbons. Before we get into the alpha ketoglutarate, we lose 1 CO2 and create some energy, 5 carbons. Then we lose another CO2 and create more energy before the succinyl coenzyme A. Here we have the S of the sulfur atom that links the succinyl to the coenzyme A, 4 carbons. As more and more the GTP is here, and we arrive to the succinate, 4 carbons. Then to the fumarate, 4 carbons here, in the middle more creation of energy. Water, and we are in malate with another 4 carbons here. And the final energy production before we arrive to the oxaloacetate. Another molecule of water will come here with the acetyl coenzyme A to go back to another citrate. If you print and stick a card with this in a place where you can see it easily a couple of times over the next week, you may be able to reproduce the elements. Once you have memorized the basics, then a lot more things can come in and hang into the frame. But this is just one example to show how well art and science go together. Thank you for listening.